Yes, to my viewers, this is now a continuation of what I had started on crashing of a project. And today we are going to do example 2 of how to crash a project. And this example 2 indicates that there's a project which has a cost in thousands of Kenya shillings and the time duration in weeks. Now, according to the question, there are 3 questions here. Draw the project network corresponding to the normal time, determine the critical path, and the total project duration. Now, this one I am going to summarize from the beginning of network analysis by drawing the network, determining the critical path, and eventually crashing the project to its minimum duration of 9 weeks. So I will start by constructing the network diagram. I'm guided by the information in column 1 and the second column, because we are going to use the normal duration. So this is how it is constructed. CVT 1 to 2. One to 2 has got a duration of 2 weeks. Then 1 to 3 that one has got a duration of 8 weeks. Then 1 to 3, then 2 to 4, 2 to 4, 2 to 4, 2 to 4 has got a duration of 4 weeks. That is the normal duration. Then 3 to 4 has got a duration of 1 week. Then 3 to 5 3 to 5 has got a duration of 2 weeks. That is 3 to 5. Then 4 to 6 has got a duration. 4 to 6, let me draw it first. This is 4 to 6. 4 to 6 has got 4 to 6 has got a duration, normal duration of 5 weeks. then 5 to 6. 5 to 6 has got a duration of 6 weeks. Then estimation of the earliest time and the latest time in this project, 0, 0. 2 plus 3, that is 2. Then this, 0 plus 2, that is 2. 0 plus 2 is 2. Then 0 plus 8, that is 8. Then 8 plus 1 is 9. And 2 plus 4 is 6. We take the maximum, that is 9. Then 8 plus 2, that is 10. Then 10 plus 6 is 16. And this is 14. So we take 16. Then that is 16 minus 5, backward pass. This is 11. 11 minus 4, that is 7. Then 16 minus 6 is 10. 10 minus 2 is 8. And therefore, the longest path, the critical path is 1, 2, 3, then 3 to 5, and 3 to 5, and 5 to 6. 1 to 3, 3 to 5, and 5 to 6. That is the critical path of that project. Then the duration is here. Duration is here. Duration is 16 weeks. Then that is the project network diagram and the duration. The next thing is I want to crash the activities so that the activities of this project, so that the project completion reduces to 9 weeks. And hence we are going to determine, I'm going to determine the total direct cost. So for us to crash the project, I had said in the previous lesson that for you to crash the project, we must determine the cost slope for each activity. And calculation of the cost slope is, we use the formula cost slope is equal to crash cost minus normal cost all over normal time minus crash time. Then we must calculate the cost slope for all the activities in this project. Let me start with activity 1 to 2. 1 to 2, the cost slope is 15 minus 10 divided by 2 minus 1. That is, normal cost is 2, normal time is 2, crash time is 1. Crash cost is 15, normal cost is 10. So this one will give us 5, and the costs are in thousands of Kenya shillings. So this is Kenya shillings, 1,000 per week. That is for 1 to 2. Then for 1 to 3, the cost slope is 15 minus is 21. 21 minus 15 all over 8 minus 5. That gives us 21 minus 15 is 6. 6 divided by 3 is, that gives us Kenya shillings 2,000 per week. That is the cost slope for activity 1 to 3. Then activity 2 to 4, the cost slope is 24 minus 20, all over 4 minus 3. That is Kenya shillings 4,000. These costs are in thousands, so that is Kenya shillings 4,000 per week. Then the cost slope for 3 to 4. Cost slope for 3 to 4 is, that is 7 minus 7 all over 1 minus 1, which is, the cost slope is 0. And this activity 3 to 4 has got no available time for crushing, because the available time is normally calculated by subtracting the normal time minus the crush time which is available. So this one gives us 1 minus 1, which is 0, and therefore that activity cannot be crushed. This is giving us Kenya shillings 0 per week. Then 3 to 5, the cost slope is, the 3 to 5, the cost slope is 15 minus 8 all over 2 minus 1. And that gives us Kenya shillings 7,000 per week. 7,000 per week. Then activity 4 to 6. The cost slope 4 to 6, the cost slope is 16 minus 10 all over 5 minus 3. That is 6 divided by 2. That is giving us Kenya shillings 3,000 per week. Then that is 4 to 6. Then the cost slope for 5 to 6, the cost slope is 36 minus 12 all over 6 minus 2. That is 24 divided by 4. That gives us Kenya shillings 6,000 per week. Kenya shillings 6,000 per week. Now, we are getting ready. We are getting ready for crushing of the project now. The other thing which we have to know is the activity duration for the project duration is 16 weeks. We have to determine what are the available resources for the direct cost to push the project up to 16 weeks. We take the column for the total normal cost. We want to get the total normal cost, or the total direct cost. We add all these. When we add all these, we get 25, that is 82. That is 82,000 Kenya shillings. Kenya shillings 82,000. That means the project is going to The project is going to take 16 weeks based on the fact that there is 82,000 Kenya shillings which is spared for the completion of the project, assuming that it has not been crashed. Now, in crashing of a project, we identify the activity with the minimum cost slope, and it must be along the critical path. The activity, first of all, the cost slopes for activities which are existing along the critical path. 1 to 3 is along the critical path. 3 to 5 is also along the critical path. Then 5 to 6 is also along the critical path. So those are the activities which are existing along the critical path. So what we are going to do here is, the viewers, what we are going to do is, we must start by crashing the activity with the minimum cost slope. And that is done with the aim of economizing on the cost of crashing. So activity with the minimum cost slope, that is 1 to 3. And the time which is available for crashing is 8 minus 5. The time which is available for crashing of that activity 1 to 3 is 3 weeks. This is 3 weeks which are available, 8 minus 5. So we are going to target activity 1 to 3 and reduce its duration by 3 days, by 3 weeks, because it is the 3 weeks which are available for crashing. Now, crashing goes on like this now. 8 weeks, that is 1 to 3, is now reduced by 3 weeks which are available for crashing. Now that is 8 minus 3. It reduces to 5 weeks. It reduces to 5 weeks. And what is the total cost? The total cost of crashing that activity is 82,000, which is the total direct cost, plus its cost slope is 2,000. The cost slope for that activity is 2,000 per week. And there are 3 weeks which are available for the crashing of that project, for that activity. That is now multiplied by 3. And that gives us 82,000 plus 6,000. That is equivalent to 88,000. And immediately we crash the activity, we have to draw another new network diagram. So this is now no longer 8. So this is 5. And this is 6. This is 6. Then 5 plus 2. That is 5 plus 2 is 7. 5 plus 2 is 7. Then 6 plus 5 is 11. 7 plus 6 is 13. So that is, the project has been crashed to 13 weeks at a total cost of Kenya shillings 88,000. 13 minus 6 is 7. And 13 minus 5 is, that is 13 minus 5 is 8. So then 7 minus 2 is 5. So the critical path is 1 to 3, 3 to 5, and 5 to 6. Now we check on another activity to crash, but it must be also along the critical path. So the activity which we crash is activity 5 to 6. 5 to 6, we cannot crush activity 3 to 5 because it has got the higher cost slope as compared to 5 to 6. 5 to 6, this is Kenya shillings 6,000, and 3 to 5 is 7,000 per week. So we are going to identify activity 5 to 6 which has got a lower cost slope. So activity 5 to 6. Now what are the days, the weeks which are available for crushing? Activity 5 to 6. The weeks which are available for crushing of activity 5 to 6, that is 6 minus 2, which is what? 4 weeks. So we are going to crush that activity 5 to 6 by 4 weeks. 6 minus 4, which was the original duration, is 6. Then 6 minus 4, that gives us 2 weeks. 6 minus 4, no, 6 minus 2 is 4. That is, we are getting now, we take that 4, we now reduce, because 4 weeks are the time available for crushing of activity 5 to 6. Then 6 minus that 4 weeks which are available for crushing, that is now, it is reduced to 2 weeks. Then we draw another network. Before we draw another network, let us establish the total direct cost, 88,000 plus the weeks which are available for crushing, that is 4, and crushing per week is 6,000. So this is going to be 88,000 plus 24,000. 88,000 plus 24,000, which is, in fact, this is Kenya shillings 112,000. And that is when activity 5 to 6 is crushed. Then let me draw a network after crushing that activity. This is 5 plus 1 is 6. 6 plus 5 is 11. 7 plus 2 is 9. So this now becomes the longest path here. So this is 11 and this is 11. 11 minus 2. 11 minus 2 is 9. 11 minus 5 is 6. 11 minus 5 is 6. Then we are to crush the project to a minimum of 9 weeks and establish the total cost of crushing. Now, we have transferred, the critical path has transferred itself because this is no longer the longest path. The longest path is now either this path or this path. But we cannot crush activity 3 to 4 because there is no day, there is no week, 3 to 4, there is no week which is available for crushing. So what we do is we check another activity which has got the minimum cost slope, and it must be along the critical path. Let us check 1 to 2. 1 to 2 has got a cost slope of 5,000, and 2 to 4 has got a cost slope of 4,000. Then 4 to 6 has got a cost slope of 3,000. Then we consider which one is minimum. 4 to 6, which is along the critical path, has got minimum cost slope of 3,000. Then 2 to 4 has got a minimum cost slope of 4,000. Then 1 to 2 has got a cost slope of 5,000. Therefore, out of logical necessity, we must crush activity 4 to 6 because it is along the critical path and it has got the lowest cost slope. The coast slope is 3,000, which is lower than any other which we have identified, and they are existing along the critical path. So we crush activity 4 to 6. Activity 4 to 6, what is the time available for crushing? The time available for crushing of activity 4 to 6 is 5 minus 3, which is 2 weeks are available for crushing of activity 4 to 6. Therefore, crushing of activity 4 to 6 is associated with the cost of equivalent to plus. There are 2 weeks which are available here for activity, for crushing of activity 4 to 6, that is 5 minus 3, times the cost slope per week is 3,000, and there are 2 weeks which are available. You multiply by 2. Then this one becomes Kenya shillings. This one becomes Kenya shillings. This is 6,000. This is 118,000 Kenya shillings. That is when the project is crushed. Then let me reduce the duration of that activity 4 to 6. Activity 4 to 6 is now reduced by 2 weeks. 5 minus 2 becomes what? 3 weeks. Alafu let me draw now another network when the duration is 3 weeks. 6 plus 3 is 9. 7 plus 2 is 9. So this is 5 plus 2 is 7. 7 plus 2 is 9. And this is 9. 9 minus 3 is 6. 9 minus 2 is 7. To the viewers, you can now see that all the parts in this project, all the paths have become critical path. This is like this is 6. 6 minus 4 is 2 here. That is backward pass. Then 6 minus 1 is 5. 7 minus 2 is 5. Then this is critical path. 2, 2, 6, 6, then 9, 9. Then 5, 5, 6, 6. Then any attempt now, all parts have become critical, and the project has been crushed. The project has been crushed. The project has been crushed to a minimum duration of 9 weeks, which is here, at a total cost of 1 Kenya shillings 118,000. We cannot crush this project any longer. Any attempt to crush it will not alter the duration of the project, since all the parts have become critical. And that is the final presentation of example 2 in our process of crushing. We will continue next time. If you have not pressed the subscription button, please subscribe, such that when we give new videos concerning wide areas, then you are not left behind. Thank you very much. Yeah.